McKenna Howard. You heard a little bit about me. Just so if you want to find me on the internet, that's my little icon, and my handle @TechGirlWonder will work for almost any social media site that I wish for the public to have access to find me. And I work for a company called Carbon 5. We're a product development agency, and we basically work with all kinds of clients, from startups all the way to like big enterprises, trying to help them take their products from concept all the way to completion. And I'm definitely going to give that spiel because they pay for me to be here, which is really cool. So this talk is called, wait, I'm a little lost here in my, sorry. Okay, let's try this again. Okay, RxJS, a better way to write front-end applications. What is going on here? Sorry. Oh, here we go. How about now? What? I'm really sorry. Just give me 1 second. This is not how it's supposed to work. Oh, God. Oh, no. Sorry. I'm giving away all the secrets. This is terrible. Oh, my God. Oh, no, now you all know everything about it. Maybe that's it. Okay. Yeah. Wow. Okay. How about now? Okay. Whew. One more time? What? Yeah. Wait. Okay. Sorry. I am going... Yes. Brief content warning before we start. Okay. Well, now you've already seen the whole talk, so... It's really great. It's a great talk. You can leave now if you want. Anyway, there is, as you might have noticed, some partially jarring animation in this talk. So I'm trying to be a little more sensitive to those issues. So if you are someone who's sensitive to that, definitely it's not super jarring, but you may want to be aware of that. And then the other thing, this isn't really a content warning, but there will be heavy pop culture references because I'm from Los Angeles, and that is what we do. So, good evening, ladies, good evening and good morning to all of you legendary children, and welcome to the Functional Reactive Programming Ball. Tonight, the category is, what is a computer program? So, I refer to a very important computer science textbook often in my programming. And it defines a computer program as a sequence of instructions designed to solve specific problems. And I think that phrase is really interesting. It's the one I always get focused on, sequence of instructions. It makes it sound like our programming is just like writing a to-do list. You're like, do this and that and that and that and that. Or if you were to think about it in maybe a different context, you might think of it like a lesson plan, basically a series of steps to do a lesson. But is it really like that? Is that an accurate description? Maybe if we were writing a command line tool, that would be accurate, but we're Java programmers, right? So I imagine there's one or two of you who writes front-end programs for the web, and this is the metaphor that I think is more apt for how front-end programs run. Basically, front-end programs don't run sequentially. The flow of execution is constantly interrupted by user input and responses from servers and a million other things. We have way less control. It's like an unruly classroom. So in a way, I think that interruptions are kind of the central challenge of front-end programming. So how do we deal with them? Well, let's learn from our history and look at a brief history of how we've dealt with interruptions on the front end. So the first idea we came up with, or that programmers came up with, I wasn't one of them, is something called the global event bus. And so I want to take you all the way back to the very first programming that I ever did, which was writing games in DOS. That was an operating system in the early 90s and 80s for those of you all who, well, hopefully you were all alive then for at least part of that. Anyway, one thing you could do in DOS is you could actually like take over the keyboard. You could do something called overriding the BIOS and basically take control of the keyboard and so that you were stepping in between yourself and the hardware and like the rest of the computer. And you would write some code that would basically take every key that got pressed and you'd put it in some kind of a buffer. And then your main program would be some kind of a loop like this one, right? It would essentially be a loop that looked at the last user input and then did something with it. And you know, essentially, on each step, you'd have to check all of your inputs, not just the keyboard. This is a simpler version. And then act on it until whatever happened that was going to quit the program would happen. There was an issue with that, which is that if you wrote a bad keyboard handler, like this is not only going to loop forever, but you can't type anything on the keyboard. So your computer will be fixed by pressing the button at the bottom of it back when we had desktop computers. Anyway, this is improved upon a little bit with Windows programming, which I touched on, which I did just a tiny bit of, but it's basically the same idea. The operating system took over talking directly to the hardware, so you couldn't do that sort of mistake there. But the basic loop is the same. You read, process, and dispatch messages. And then the main logic of your program would be to handle different messages, right? And it usually ended up looking like a big switch statement where you did something based on the message that was passed. And that's sort of the pattern, and that takes us all the way up to like 1999 or so, right? And when we moved on and left that in the dust for much better things. But actually, if you've been programming recently, that sort of pattern for like for updating state based on dispatched messages, if you happen to be programming in React, you might notice that that looks a lot like a reducer. And in fact, Redux contains a whole lot of the global event bus pattern. While Redux may be programming like it's 1999, in reality, there are some good reasons they went that way, and we're going to see in a second. But I want to go ahead and move on to the observer pattern, which is basic. Apart from Redux, this is how we've written front-end applications for the last several years. Before we get into that, I need to make a short digression, if you all don't mind, into the world of influencers. And it's going to help us understand the observer pattern, I promise. So let's say you are a content creator on the internet, and you know with your typewriter you have something very important to say, and you're wondering, how will people see my content, right? So in the pre-internet age, you kind of had to be like Liam Neeson, and you had to track down anybody who you wanted to see your content and just like force them to watch it. But fortunately, now we have a better way. We have like a contract. I, as a content creator, promise to publish content, and then you, as my adoring fans, use one of our many and numerous scary social media surveillance platforms to subscribe to it. And then when I publish new content, you'll essentially automatically get notified without me having to go track you down, right? So this, in short, is the observer pattern. Here, our influencer is called the subject, and they essentially promise that they will emit events in the future. And then you have an observer who subscribes to those events and then can act on them. So that's the basic pattern, and you actually probably use it every day. You probably use this in your JavaScript code without knowing it. I'm going to look at a really short real-world example. We use this pattern. I'm still like rewinding myself from the beginning of this and getting myself onto the right slides. So sorry if I'm catching up. But okay. So let's say that we have like a DOM, and the DOM has a toggle switch. And we want to make it so that when you click on that toggle switch, it changes something from on to off. So we have our toggle switch. There we've looked it up. And then we have a function that is going to look at another element in the DOM and basically switch its value from on to off, right? So this is a pure function, and then we have this element. So the way that we connect these two is we essentially subscribe subscribe to mouse clicks on the toggle switch and then pass it to this function, which is now an event handler, right? It is now an observer of the click events on the toggle switch, and that means that when we click the toggle switch, we'll switch the text in that other element. So that's the basics of the observer pattern. You've probably been using it without knowing. So, cool. So there's some really cool advantages here, right? Sorry. It's way simpler than the global event bus, right? Like, we didn't have to write a giant loop. We didn't have to write a big switch statement. We just attached to what we cared about. And so it's really localized, right? You just subscribe to only the things you care about, and then you process them when they happen. The downside is that you have to set up subscriptions, which initially doesn't sound like a pain, too much of a pain, but as a take-home exercise, I highly encourage you to try implementing drag and drop, or if you've ever done this, implementing drag and drop with like mouse down, mouse up, and mouse over. It's quite a challenge. And a lot of the problem is that you're actually mixing concerns, right? You have, on the one hand, you're handling events, right? So you have these event handlers, but then the event handlers themselves have to also set up other event handlers, because like basically when you do the mouse down, then you want to start tracking mouse move, and then when you get the mouse up, you want to stop tracking mouse move. So there's a lot of different logic. It gets pretty complicated. And the observer pattern is really great, and it's been around a long time. It's reliable, but it's not really perfect. So this is my theory of how Redux got created, is that the Redux creators were looking at this global event bus. We're looking at the observer pattern, and then they saw the global event bus, and they were like, maybe there's something valuable going on here. But you might be wondering, like, maybe there's just a better way to do all this. Yeah? So that's kind of the rest of my talk. This is about how you can use functional reactive programming to write front ends like a boss. I want to return to my original metaphor of the middle school classroom. And actually, in reference to the speaker, I did actually teach, but the lie is that I taught middle school, not high school, which is arguably even harder, but it wouldn't matter either way because I was terrible at it. And this is not a talk about how to be a bad teacher. This is about how good teachers handle situations. And if you've ever like watched a good teacher in action, they're kind of Jedi-like, right? Like they have this ability to like Obi-Wan the students into like thinking this is the lesson they're looking for, right? And so how do they do that, right? They do it. The first rule is that like the lesson plan is not like a series of steps. It's not a plan. It's kind of more of a guide, because if they treat it like a plan, they're just going to get interrupted. Instead, teaching, you can almost think of actual teaching as a series of planned responses to interruptions, right? And really good teachers know how to not just respond to the interruption, but to sort of like fold that interruption back into the rest of the lesson, right? And they have this way where it just sort of like each interruption gets folded into this stream of learning that all always ends up on the key objectives of what they're trying to teach. So in that sense, it almost is Jedi mind control. PSA, as someone who is really bad at teaching, I highly encourage our society to pay our teachers a lot better than we do. Well, what does this have to do with programming? How do we write programs where we write them as planned reactions to interruptions as our core concept? Well, so I want to take another digression into just some pure conceptual stuff. Let's look at this statement, really basic, y equals x plus 3. You've probably written something of this sort in your programs at some point in your programming career. And if we think about it in our traditional sense, in the imperative programming world, this is an assignment, right? You're saying that y is going to be equal to whatever the current value of x is plus 3 one time. And now it has that value, and it will be that way for a while. But, and I can tell you already, there's a missing image coming up in this one. I'm not sure what happened. if we think about math, in math it actually has a different meaning. In math, y equals x plus 3 can express an entire graph, right? You can express, it expresses a, what is it, like a slope-intercept thing on a graph? I'll have to talk to the math majors afterwards. But anyway, that's what it should, there should be a graph there, there's not. So it doesn't have to mean that. And if we look at reactive programming, this statement, y equals x plus 3, could actually express a relationship between y and x. And it's essentially saying that x is a value that could change over time, and y is a value that will always be that value plus 3, right? So if you imagine, oh my God, what's going on with my images? Jeez, okay. I don't know what happened, but darn. I'm not going to troubleshoot this because we don't have enough time. Sorry, this was working as of like 2 seconds ago. You can imagine a line with lots of x values on this. God, technical difficulties in this talk. And you can imagine y as another line that doesn't look like a broken piece of paper. And there's another line of values under it, and each value for x has a value for y underneath it that is that value plus 3. And then you can even imagine another missing line. And so those are both like a stream of data values over time, but a stream could be a stream of anything. It could be a stream of mouse clicks over time. You can imagine just like every time the user clicks a mouse, you add a new value onto this stream, right? So reactive programming is essentially programming with streams of data. That's all well and good, but how would we program this on a computer, which is basically written to use, to work imperatively, to execute instructions? We need some kind of pattern where, like, every time a value changes, you could, like, subscribe to it and get notified that it was changing. And I feel like we've heard of that pattern. It's actually the observer pattern. We just need to basically extend it and make it a little better to handle kind of like arbitrary things, right? So in reactive programming, we have a concept called an observable. And an observable is essentially a value that changes over time that we can listen for changes on. But it can be anything. So let's imagine a value as an observable. So let's imagine we have a value x that is a value that changes over time that we can subscribe to. And here, you could write out the changes to x. And then you can imagine if you wanted to write out the values of y, you could just subscribe to the changes on x and log x plus 3, right? But what if we actually wanted to listen to the values on y, right? So to figure this out, let's rewind for a second and just imagine x is an array, right? So it's an array of values, and if we wanted to get the array of y values from this, in JavaScript, in a lot of programming languages, we could use the map operation, which takes essentially an array of values, goes through each one, transforms it, and gives you back the array where each value has been transformed by the function. So an observable actually works the exact same way. Here we have an observable of these numbers, and here they would just be outputted immediately, but we could think of them as happening over time. And we could think of y as the observable x mapped so that each value is the emitted value plus 3. And that produces another observable we could subscribe to. So this is where the magic of reactive programming happens. You have these observables which you can compose and continue to sort of like build up to do really awesome things. So let's look at some cool stuff. This is going to be our first interactive demo, and I need to get over to the confidence screen, given the... Okay, so here we have a ball, right? And P.S. Full disclosure, this is animated with a library. But we could, let's say we have these 2 buttons, right? And the buttons, we can use them to, oh my goodness. We can use them to make the ball go left and right? So let's imagine that each time we click on one of these buttons, it's an observable, right? And so we have our left button clicks and our right button clicks. And if I click on the right button, we can imagine that we would get a click, right? So then what if we take each right button click and translate it to the string right, and each left button click and translate it to the string left, right? So now if I click, it becomes right, and if I click left, it becomes left. So then let's now further imagine that we make an observable that uses the left click position and the right click position and just takes whatever the last one to emit is. So now we have like a left click, and a left click, so the position is left, and if we had a right click, then the position is right. So you can see that basically by doing this, the position is now an observable of the correct position for the ball to be in, right? Now the actual animation in this case is being done with this library called pose, but you can imagine, but it's not that complicated to do. So how this actually works in code, and here's where we're going to introduce the library that we use to do reactive programming in JavaScript. It's called RxJS, and we have two functions here to create observables. One that it makes an observable from an event, and one called merge, which takes two observables and outputs an observable that emits both of their events. So, and then we have some operators. We have a map operator, a start with operator, and delay we actually aren't using here, but that's what is being used in those animations of the actual signals. And so here you have like a left button and a right button we've just looked at from the DOM, and then we've made an event stream of both of their clicks. And then this is actually mapping each one from a click to a string. And in actual RxJS code, we use this pipe operator, and then we put our different operations in the middle. And the cool thing about that is you can do multiple of them. So here we're piping the left and right to a position. Oh, sorry. And then finally, we're merging them, right? We're using that merge operator to take the two of them, and we're adding one other thing, which is we want to start it in the left position. Cool? So how do I actually use this in my daily life? You're all excited. This looks cool. You saw a bouncy ball. But how do we actually do this? Well, I want to first talk about something that I noticed. How many of y'all went to Laurie Voss's talk on NPM? Yeah, a bunch of you. You all remember this graph about the React ecosystem? So when he had it up, I was looking at it, and I was like, wait a second. What's that green line? Wait, isn't that... I was like, holy moly, it's RxJS, and it's got more downloads than React. So the short answer, we actually spent some time yesterday. I spent some time with Laurie trying to figure out how this happened. As it turns out, RxJS is used by some key libraries, namely Angular and ESLint or dependencies thereof. So it's installed by that. So even if you aren't programming with RxJS, you actually are. It's somewhere. It's a lot of the people whose libraries you depend on program with RxJS. But I want to talk about how you would use it to actually write programs of your own. And I want to address two areas. One is first, how do I actually architect a real application with RxJS? And how do I integrate this into my applications today? So let's talk briefly about a much more real-world example. And here we have a login form, one of our classic, software challenges. You have to be able to enter a user and password. When you submit, you probably want to disable everything until it comes back with a response. You have a user, you want to give a message or something, if the server tells you that something went wrong, you've got somewhere in here an asynchronous call out to a backend. So there's a lot going on here, right? And so in assembling this, we could start with 3 observables, a username, a password, and a submit button. And basically, the username would emit any time that I change the value of the username, and the password would emit every time that I change the value of the password. And the submit button, you can think of just going whenever I click the submit. So then, if I were to express the act of attempting to log in, it would essentially be the every time I click the submit button, take the last value of the username and password and attempt a login with them. So here, so essentially with that, if I actually if I submit here, it takes those last values, and you can see the username and password there are the last thing that was emitted from those from these input boxes. And so then, once I have a login attempt, Then I need to process the response that I get back from the server, and that could be either a success or a fail, right? So basically, once that comes back, I'm gonna go ahead and I get my attempt, and then I get a response. In that case, it's a failure, right? Once I have that, I can do some more stuff. I could filter down to just failures and just successes. I might be able to derive like a login in progress from the time between a login attempt and a login response, and that might be useful for like disabling all these inputs while the login is happening. And then I might have, then once I have a failure, I might want to convert it to a message so I can display it on the screen. And lastly, if I have a success, I might have a user token, and I might use that to get some like protected data from the server. Taken all together, you have like you could do quite a bit of functionality with observables, and I'll show you the actual code for this in a second. But you can see here, like you see a failure message sort of trickling down into the final fail message. And then over here on the login in progress, you have like it tracks whether or not you're logging in. And then if we were to do a success, which is JSConf and awesome, then we get a success, and that gets a user token, and that gets a protected resource, and then we get your final like saved data. So you can imagine it filtering around here. How would that actually happen in code? It's not actually as complicated as you might think. Making that little graph is pretty complicated, but writing the code to do this is not terrible. Let's just imagine we have an API with a login and with a login endpoint and a protected resource endpoint of some sort. So there's our API. And then let's just say we have our username, password, and submit button. I will get to how those tie into the actual UI in a second. And then we can do our login attempted just becomes the submit button with an operator from RxJS called with_latest_from, which basically just says take the latest username and password and add it to whatever the login attempt, whenever the submit button is clicked. And then we have a login response uses this amazing operator called merge map in RxJS. And here we actually make an API call which returns a promise, which is not something that has an immediate value. But if you use merge map, it essentially takes, what you do when you make the API call, if you were to just use map, you would get a stream of promises. But merge map will reduce those down to just their underlying values when they arrive. So this actually gives you a stream of the responses. And then the login in progress is just expressed as essentially every login attempt flipping it to true, and every login response flipping it to false, and starting with false, right? The login successes can be expressed by taking the login response, and just like we would with an array, we can use a filter operator, right? And here we're filtering and just taking the status and converting it to a success. And then a login failure would just be the same thing, but filtering on the status being failure. A login failure message would be taking all the login failures and just piping them to a map operation to extract the message. A user token would be extracting a token out of the success responses. And then we could start the whole sequence all over again to get the protected resource. And here we're taking the user tokens and piping those to make an API request with the user token to get a protected resource. So that's how you could do some very complex functionality in not a whole lot of code using RxJS. Now that graph you've seen is a really important concept in RxJS that the more you get into it, and I wish more people knew about this, it's called a signal graph, right? And it's how data propagates through your program. And it's a really useful tool for thinking about your programs. And gosh darn it, I figured it out, it's SVGs. So that's an SVG, but it's an SVG of a real signal graph. And I've actually programmed on production applications where the whole team maintains this signal graph as a way of like producing a shared understanding between the whole team about how you're doing, about basically how the data model of your entire application works. So how would you use this in real life? I'm getting real close. So let's talk about integrating it in actual stuff. First of all, if you use Angular, and I actually don't use Angular, but if you do use Angular, it's like basically baked into the framework in a million ways, and there's a million really easy ways to use RxJS in Angular. Also, you might want to check out NGRX, though I also encourage you to like not, that's sort of like a big library that kind of operates like Redux, and I encourage you to like not jump right to using the library and try learning a little bit more about how Rx works. But let's get to the question on everybody's mind about React. Because if you're writing a program in React and you have Reactive JS, wouldn't it be better to have like Reactive in your React? So there's good news. I am here to offer you something in this. There's actually a whole bunch of different ways to integrate React with RxJS. And full disclosure, I'm going to present my way, as in the software that I wrote, because I'm talking. But there are a lot of other great alternatives, and I highly encourage you to look at them. So I wrote a library called RxReact, and it's a series of tools for integrating React with RxJS. And in fact, everything you've seen in those interactive demos was written with RxReact. And the way it works, it's pretty simple, actually, right? Let's say you have, in this example, this is our box that's like moving backward and forward in our screen, right? And what we do with RxReact is we define something called a view model. This is similar to, this is basically drawing from a pattern called model view model, which basically a view model is like the thing that supplies the data to the view, which just does the presentation, right? And in this case, with a view model, it connects our observables into props in React. In this case, here's our inputs, and for each input, it's going to convert the observable. Here we have a position observable into a prop called position anytime that's going to update anytime it updates, right? Oh, sorry. And each input's an observable that becomes a prop, and you define this as a view model, and then you import from this library RxReact core, because RxReact was already taken on NPM. You import a function called withViewModel. And viewModel is just a higher order component that takes your view model and binds it to your regular components. So now this component, anytime the position observable updates, it will re-render with a new position prop. And you can do the same thing actually for events. You have these things called outputs, and for an output, each value here is a special type of observable called a subject, and you saw those in the slide earlier. And essentially, it converts it from so this subject, the left-click subject, you will get in your component, you'll get a property called onClick, which is itself a function that when you call will put a new value onto this onClick observable and emit it, right? So this basically it converts from an observable emitting from a function to an emitting an event on an observable. You can actually actually you can do pretty complicated stuff pretty easily. This right here is the code for that entire login form that I showed you a second ago. We have our username and our password as inputs, our login in progress state, our login failure messages, and then we also have a username and password change, which are the outgoing, and this has to do with the way that React does inputs, where you have to both like send it the new value and read the events if you want to do a controlled input, and you have a submit button, and that's all that's needed to connect that login form. So now we come to the final portion of this talk, which is I call the used car sales portion, because I'm going to go very quickly through all the amazing cool things you get when you use RxReact if you act now. One thing it has is these view model factories. Like, let's say you want to change the observables based on the props external to the component changing. Well, so you can use a view model factory to do that. You use the same function, the withViewModel, and you're probably wondering, but what about TypeScript? Because you care about your stuff not breaking. You are concerned about the security of your shit. The good news is that RxReact is written in TypeScript, because I love TypeScript too. It actually has, I'm not going to get into it, but if you're in TypeScript, it has really awesome type checking where like all the props have to line up and all the observables have to line up and like you won't mess up and whatnot, or so I claim. What if you're like, I like observables, but I also like reducers, because they're very hot right now? Well, what if you could write a view model based on a reducer function? Similar to sort of the syntax of ReasonML, which is Facebook's new hotness in terms of like the way they want to take React in the future. Well, guess what? There's another package called RxReact / reducer, and it is also somewhat available now. I actually don't know if I published it, but whatevs. And the coolest thing that fascinates me is like those signal graphs. And I just imagine I would really like to be able to automatically render one of those interactive diagrams so I could watch my programs do that. Doesn't exist right now, but I've got a lot of ideas, and I'm really working. And one day there will be RxReact / signal. But in the meantime, I highly recommend RxReact / core. I've used it enough that I think it's not terrible. So that's all. You can find my slides right there, and the GitHub will be on the slides when you get there. And thanks. Let's go get a slushie.